Okay. Probably know that. Good morning, everybody. Welcome back from spring break. I hope you guys are all doing well. I don't know about you guys, but I appreciated the break. Though it wasn't much of a break, but it was a break from classes at least, which I appreciated. Today we're going to continue on with our operator overloading discussion. So we're going to go ahead and do just a quick, review through the notes. And today we'll be developing that string class that I talked about. There is another assignment on Web Campus. This one is already ready to go. So unlike last time, if you just go here and check in the assignment, you can see all the files are there. I'll be going over this today. It's a straightforward assignment. There's no tricks and turns. You don't have to know how Mastermind works. We're just overloading a bunch of operators for a class. There's a small extra credit opportunity within this assignment as well. So I will be going over that shortly. And then if you come down here to assignment 6, you can see that it is due on Saturday. And the late date is on Sunday. So if you do get started on that, be sure to ask questions if you need. Tomorrow, hopefully, I'll have some time. I'll get started grading on the virtual assignments that you already turned in. And so I'll have those done this week. I'll also have the extra credit for those of you who did that done this week. And I will grade that extra credit as if it is an assignment. So there's a chance that you won't get the full 100 points if there's something that I see in there that I don't think qualifies as the virtual edits that I discussed. I will let you know if and where I found those. But it appears a lot of you asked me some questions, and I think we got it worked out. So I expect some of those extra credit grades to be pretty nice and hopefully helpful to some of you guys. So if you have any questions, please go ahead and throw them at me if you need. I'll just keep that there for later. And let's just kind of quickly go through all the notes that we talked about last time. Today, we're not really going to write any more notes. We're just going to really go over a bunch of operators, an example of those, especially the operators that you're going to be using in the assignment. So, if you remember from last time, which was over a week ago, almost 2 weeks ago, we talked about these things called friend functions. And we will code some of those in our example today. And remember that whenever a friend function is just a normal function that's possibly defined in the global scope. It is not a member of the class, right? And if that class has some private or protected members, we can deem one of these functions to be a friend of that class, like this, in which notice that the global, my face is kind of in the way here, that this global function out here can access the private member of class A, as long as we say, hey, this is a friend somewhere inside the class. And so we're going to use these for the operators today that we do. You see that they're very helpful, and they are required in some cases. Today I will be asking some questions about this left-hand, right-hand stuff, so just remember what I'm about to say here. So we began our operator overloading discussion, and I gave you a link to all of the operators that are available in C++. And recall that when we say LHS, that's our left-hand side of the expression, and when we say RHS, that's our right-hand side of the expression. Now, we did talk about some operators that cannot be overloaded. It is these 5 operators here, so don't even try. You have used all of these before, and I at least showed you how to use the ternary. Maybe you haven't used the type ID, but regardless, you cannot overload these operators. And so then I gave you a quick example of what an operator overloader is, right? In which, if we're adding 2 numbers together, we're kind of doing a math addition, right? We're doing, that's what I call it. But we're doing addition with numbers. But the string class, which we've used for almost 2 semesters now, this has an operator overload for that same operator plus. But when we do plus on some strings, it is not math addition. It is actually concatenation. And so string has overloaded some of these operators so that we can use them for other things. So what are the requirements that we need to overload our operators? Well, we need a class that we defined, right? We can also use a string class, like we said earlier. And then we also need a C++ specified operator that we're going to overload. Recall, and this is kind of a test question here, we cannot make our own operators because it's going to confuse the compiler, okay? So if you feel like you need to make up some symbol or some operator that is not already a C++ operator, you might as well just make a function. Okay. And operator overloading and functions are almost the same thing. Except operator overloads can be called in a nicer, I would say prettier or more aesthetic. It increases our readability of the code, right? When we say, or when we see something like this, string X plus string Y, this might be more readable than, say, something like string, or it might be something like cout X dot concatenate Y, something like that, right? Now, some of you might prefer this. But there's just 2 different ways that we can read this. And so that's really what operator overloading gives us the opportunity to do, is to make our code more concise, more readable. And remember that I said some operators can be members of our class, and some operators can be globally defined, meaning they're not a member of the class. And this is where we use our friend functions. So recall what operators have to be member functions. I gave them to you here. This is test question right here. And it's the assignment, the bracket, and the parentheses. Now, why do they have to be member functions of that class? Well, it is always because there's an object on the left-hand side of this operator. There's always an object of the class on the left-hand side of these operators. There's never a case where there's not. And so in this case, these operators have to be member functions, and there's no other options. And then down here I say, what operators have to be global functions? Well, only these 2, the insertion and the extraction operator. And the reason for this is just the opposite, and that the object of the class is actually always on the right-hand side. And so we can't access that object before accessing the operator because it is on the right-hand side. So we'll actually see the stream first before we see the object. And so every other operator can be either member or non-member functions. I'm going to ask you guys a quick question. Down here we just did the syntax, right? So if you need to reference that, you can. We're going to get started coding here. But I am going to ask you this one question, and I want to see what you think, because it will be helpful for both the assignment and what we do today. So up here we got this string CS202, right? And so let's say that we're going to overload the addition operators. All right, so I kind of put operators to do here. So today we're going to do some pluses. We're going to do some multiplications. We're going to do the brackets, the assignment, the insertion, and the extraction. I might have got those mixed up. I always do. So we'll just put that up top. And here we have our code. Notice I deleted some of the code that we wrote last time, so I'll just kind of refresh you on that. But we're making a string class. Okay, strings are represented with an array of characters. All right, so we've got our pointer here. And then we need to know the size of the array. This kind of looks like the dynamic array class that we did earlier this semester. Right, we've got an array of some sort, and we've got an integer for the size. Now notice here that I just left in the default constructor. I'm even going to bring in this bracket up top because it has no body. But we do initialize this character array to be null because it's a pointer, right? And then we do initialize the size to be 0 because when we create a string, and if it's the empty string, then it has no characters in it. So the size of this array will be 0. So let's say down here in main, and this code won't compile yet, but we'll get it to that point. Let's say I make a string CS202, and we'll call it maybe string 1, and I want it to be like, let's call the parameter constructor instead. And in this case, I'll say something like loaf. And then let's say we make another, well, let's actually stick with just this. And then let's say I wanted to do, I had said the addition. I don't think we're going to do, well, we won't do these integers this way. We'll just do string plus string. But we will do the multiplication ones, right? So I had mentioned this before in the notes. So let's say I wanted to do something like cout S1 times 3. And then let's say I also wanted to do something like cout 3 times S1. So what these are going to do, the way we'll code them at least today, is it's going to take that string and it's going to multiply it by 3 so that we would get loaf, loaf, loaf. And this one will do the same thing. If this happened to be, say, 2, then we would only have 2 loaves. Okay? So let's just go ahead and make some operators so that it works like this. So in this one, notice which side the object is on and which side the integer is on. Right? So notice that we have the object on the left-hand side and we have the integer on the right-hand side. And if I come here and check my notes, it says every other operator can either be a member or a non-member. So let's go ahead and just make this one a global function. But remember that the order of the parameters matter. Let me put in some notes here. Multiplication operator. So notice that this operator, it looks like it's going to return a string. Just as 3 times 3 returns a new integer, right? Int times int returns a new integer. So in this case, a string times 3 is going to return a new string. So just like any function up here, I have to say string, right? Here it is. This is our class. So that's our return type. And I'm sorry about that. I'll put my phone away so you can't hear it buzzing. And then remember that we want to do an operator. So if we're going to do that, we can reference the notes for the syntax, right? But we're doing the multiplication operator, right? So I'll type this here. And then it needs parameters, right? And I said order matters here, right? So if I'm overloading this operator, what needs to be the first parameter and what needs to be the second parameter? And you can just say the types. But I am going to wait a little bit to see if we can get you guys to wake up a little bit and back in the computer science mind. So Awful says object int. That is correct. So guess what? The object is going to go in the left-hand side of this parameter here. We'll just call it LHS. I like to do this. And I would recommend doing LHS and RHS when you do stuff like this because it is helpful. And so then the int is going to be on the right-hand side. And then we're going to have to do some stuff in here. Before we do that, let's make this a friend function. So first this needs to be a friend function. So what we'll do here is we'll actually just copy this thing. And we'll come up into here. It can be in private or public. But I'll just put like a friends below here. And it's just like a function prototype. So all I have to do is type friend. And that should work. Yep. So I'll just put friend, CS2 operator, multiplication, right? And that will give this function access to these parameters. Now, before I code this, I'll ask you this, and I've been saying over and over again, order matters. So this operator here, in fact, it's not going to work with this one. Okay, it's not going to work with this one. And that's because the integer here is on the left-hand side. So with that knowledge, I'm going to have to define another operator for this. It's going to be the same thing. But let me ask you, can this version of the multiplication operator, we know that this one can be a member of the class. But can this one? And what do you think and why? So if this operator is taking these parameters in this order, do you think that it can be a member of the class? I'll even take a yes, no, if you're not feeling talkative today. So Red Rose says yes. Any other votes? So the parameter ordering is different. That is correct. But when we come to our notes here, and we talk about this, I say what operators have to be member functions? And it's these ones. And it's because there's always an object of the class on the left-hand side. And then when I say what operators have to be global functions, it's these ones. Because there's always an object of the class on the right-hand side. So notice here that the object is not on the right-hand side. Or it's not on, sorry, excuse me. This is not on the left-hand side. It is not on the left-hand side. And so because of that, this actually cannot be a member function. Yes, exactly. Yeah, Espeon got that. Exactly. This one has to be a global one. Now, it's not to say that this operator can't be a member function, because it can. It absolutely can be a member function, in which we would just cut this part out, right? And then we would copy it and move it into this function, or into this class, because then we would be working with the this object, and the this object is always on the left-hand side. But in this case, since the integer is on the left-hand side, we cannot actually make this version of the operator with this ordering a member function. It has to be global. And so we'll just say this. So always just remember that. What is the ordering? And the ordering will tell you if it can be a member function or if it can be a global function or both. Am I still here? I had a little bit of connection issues. Yeah, we're having some small connection issues. Like I said, every day around noon it happens. Even though daylight savings time hit us, it still knows. Yeah, we'll wait. We'll wait a little bit. All right, so I'll take just a step back here. And you'll see here kind of what I put in the notes. And all I said was that because this operator has an ordering in which the int is on the left-hand side, we cannot make this ordering of this operator a member function. This one has to be global. Yeah, no problem. That's the point of this, right? And so that's kind of the rule, right? When you're taking a test, always just think about this. And it will help you, especially with these ones. You don't even have to memorize these operators because you just have to think about how they're called and if there are any other options, right? So in this case, the object is always on the left-hand side. You have no choice. You have no choice. And in this case, the object is always on the right-hand side, so you have no choice. In this case, you do have the choice, but your choice depends on whether or not it can be a member or not. So, as long as we understand that, we'll be good. I'll probably add that here in the notes. So I'll just say this. If the object is not on the left-hand side, the operator will have to be a global overload. Fair? So let's go ahead and start overloading these operators. Got to get started at some point. So before I do any of this, let's go ahead and do a few things, right? Remember that this array is this is a class that contains a pointer. And because it contains a pointer, here you guys can say hello to Miss Loaf for just a moment, and then she's got to go. We need to do the rule of 3 stuff, right? So let's just do that. So the first thing on our rule of 3 is we need our destructor. You'll have to do this for the assignment anyway, so you can kind of just look at this one. For the destructor, we have to delete this array, right? We have to delete it. That's what it does. And so in the destructor, we're just going to make sure that we deallocate that array. That's it. The next rule of 3 is going to be a copy constructor. And so what does that look like? Well, so that is a constructor, string CS202. That is a constructor. And this constructor takes in another object of the class. So it would say something like this, string CS202. But most likely, the compiler will be upset at this because this is a constructor. And so for some reason, it wants you to make sure that it's a constant object and that you're passing it by reference. And so we won't fill out this one yet because I'm going to show you a trick. Okay, so if you can see here what I put in the notes, we can use the assignment overload to make this easy for us. And then the last thing we need is that assignment operator overload. And so this one, remember, has to be a member of the class. Where does that say? It says right here. It has to be a member of the class. And in general, do assignments return anything? No, they don't. I'm sorry, you gotta go. In general, they don't. And so we'll just make this a void. We'll give it this operator equals, right? That's our assignment operator. And it's going to take a parameter, right? It's actually going to take the same parameter that the copy constructor does. Right? Because when we're down here, and then if we say something like string CS202S2, we'll call this Patty. And then if I say something like S2 is equal to S1, notice that this is the parameter, right? And it's the exact same thing as calling S2 operator equals while passing in that parameter, right? And notice if we call it this way, it's pretty obvious why the left-hand side matters. Because you need the object to call the operator from, right? If we were doing an int, 3 times operator multiplication S1, the compiler says this is not an object, right? It says this is not an object. And so I hope this is a global function because I don't know what to do with this, right? So that should make sense. So those are kind of the same thing. And so this is the copy, right? The copy's on the right-hand side. Since this is an operator, let's do it this way instead. And let's put in our comments that this is the left-hand side, right? When we come down here and we look at this operator overload, we notice that this is how the operator is being invoked using the S2 object. So the S2 object is in fact this object. And so we're just going to say that right here. This is the left-hand side. And we'll just put it in quotes to remind everybody that we're not talking about this, but we're talking about the pointer this. And so recall that we have to overload this because we've got pointers in here. And can anyone tell me what the name is of this? I know I've asked this before, but if I say this array is equal to the right-hand side array, what is the term for what I just did here? And it only applies to this one because they're pointers. Right-hand side size. I'll give you a few more seconds and maybe a hint. We talked earlier about things. Yeah, Sibe got it. There we go. That's the shallow copy, right? Versus the deep copy. This is a shallow copy. And why is that called a shallow copy? It's because we copy the address, right? We say, hey, this array's address is now this array's address. And that's bad, right? Because then, let's look at paint. Here we are. So we've got object 1 here. We've got object 2. And inside these objects, we've got the array, right? Which is a pointer. So in a deep copy, these arrays each point to somewhere in memory. Let me do a nice fill here. These arrays each point to their own location in memory. What does that memory look like, right? It's some address. I'll zoom in here a little bit for you guys, right? So it points somewhere to 0x, say 00A or something like that. And then this one also points to 0, maybe x0, b2a, something like that. My face is probably in the way here. So we have two string objects here, right? Pointing to their own locations in memory. As soon as we say array equals, right-hand side dot array, and if this is the right-hand side, we then say, okay, we're going to erase this address. Whoops. We're going to erase this address. And then this is now pointing to, maybe I can just use a pencil here. This is now pointing to, can I get a nice bigger one here? Ooh. That exact same address, right? And so now we have two objects sharing one array. And so what happens if this object here goes out of scope? Well, it deletes the array. And so what does that do on this one? This array is now deleted. But this object is still in the scope. So do we have a problem? The answer to that is yes, we do have a problem here, right? So that's the shallow copy. And so what we have to do is avoid this. And we have to do a deep copy, right? So the first thing is we'll copy the size. And then we're going to say, hey, we need to first off delete this array. We need to say, make sure we deallocate anything that we had here before. Let's delete that array. That's step one. Step two is to then allocate a new array. Array is equal to new character with our size. Notice that I had changed the size up here, so this works. So that's step two to allocate. And then step three is the deep copy. So we're just going to say for int I is equal to 0. I is less than our size. I plus plus. This is step three, which is the deep copy. So what is this one called? This is the deallocate step. This is the allocate step. And this is the deep copy step, in which we'll go through these arrays one by one, and we'll say, hey, the array located at this index is also equal to the array from the right-hand side, located at this index. And that's it. Does anyone have any questions about this operator? This is our operator here. What did we do? We copied the size. We deallocated the old array because we don't need it anymore. We then allocated a new array so that it has its own location in memory. And then we went through the array one by one, and we just copied each character into that array. So this is a nice deep copy. And this operator is now overloaded. Okay? So whenever we're down here and we do something like this, it's going to work with no memory leaks whatsoever. So now, pay attention to this. This will make your assignment easier. This copy constructor works almost exactly the same way. It works almost exactly the same way. Except there's one thing that doesn't matter. There's one thing that doesn't matter. And it's that we don't have to delete an array in the constructor. We don't have to delete the array in the constructor, and that is because it is a constructor, meaning that this object had not existed before. I think you all can agree with that. Since this is a constructor, we know that this string is just being born. It's just being born into the scope. And so we know that this array has nothing in it. Now, to be picky here, I'm going to initialize that array to be null up there. Because if you recall, when we do something like delete array here, if array is null, it will still work. Okay, so if you remember that, if the array is equal to null, then this is going to work. And so if this array is null here, then it will still work, is all I'm saying. So how do I use the assignment operator here to make our life easy? So, remember this. This is a fun trick. This is a pointer, right? And if that confuses you, we can do something like this instead. in which we go to the address of this object, right? So we'll go to the address of S2. We'll go to the, well, we're doing this one. Yeah. Sorry, we're going to do a copy constructor here. String CS202, let's make S3. And the copy constructor will be called like this. So in this case, we're passing in S1 as an object. So S3 is the this, and S1 is the parameter. And so what we basically then say is we say S3 equals S1. Does anyone have any confusion with what I did with that? I have to dereference the pointer. I have to dereference the pointer in order for this to work. When I dereference it, it becomes a string CS202 type. And so then I just call the assignment operator here. And so it will come in here and it will do all this deep copy stuff for us. It'll do it all for us. And the delete won't matter. But at least we didn't have to write that much code. So please let me know if that's confusing to you at all. We'll spend some more time on it. But please do this in your assignment. You don't have to, but it'll make your life easy. So we just did our rule of 3 and our first operator overloader, right? We did our rule of 3, we did our destructor, we did our copy constructor, and we did our assignment operator overload. And so now we'll finally get started on this stuff. It's always important to have these things available. There's also one thing that I would prefer to have as well. We have to make one more. Constructor. It works like that. So this will be our parameter constructor. Now this one I kind of might just wave my hands a little bit. But do you see down here we call this parameter constructor here. And what do we pass in? This is a string. This is not a string. This is actually a character of array, or it's a character array. And so what loaf actually looks like is it looks like an array that's like this, where we have we've got L, O, A, F, and then we actually have this at the very end of it. This is what's called a null terminated. Now this won't be on any tests. It's just good for you to know that whenever you do something like this, whenever you say cout something like this, this is a null terminated string. And even though you cannot see the null character at the end, it's there. And so even though the size of Bob is 3, the character array is actually size 4. And in that last bit there is a null character. And does anyone have any idea as to why that is? How does this help us? Or why would the compiler do that? Especially if I'm up here doing this. Well, do you guys have any thoughts? Especially when I'm doing something like this, right? Why would I want to know where that null character is? I'll give you a few more seconds. Yeah, Red Rose, I'll give that one to you. And let's see, to make sure you're in scope. I like that as well. You kind of both have it in a way. The short answer is that this tells us where it ends. It tells us when this string literal, when it's done. Because if we didn't have this here, we might have some garbage memory following it. And so it might be blah, blah, something like that. Dot, 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 etc, dot, 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 7685x. And so how would the compiler know that the string stops here, or if it stops here, or if it just keeps going off into garbage memory? And so the compiler will put this null terminated, or put this null character at the end to tell us, hey, it's done here, okay? Because these character arrays don't have a size, right? This thing does not have a size. And so when I am building, when I'm passing in this character array, I could also do it like this. When I'm passing in this character array, but we'll do it like this. I'm going to first read to see how big it is, right? So I'm just going to do while array located at size does not equal the null character. So what's this say? And so if array.size does not equal the null, then we'll just say size plus plus. T. Peter says, if you try to access the null terminated character, you get a seg fault, right? In fact, you won't. You won't. You would be able to say something like cout array 4, but this would print a blank. Is that right? No, it would be, because this would be 0, 1, 2, 3. So this might seg fault, but this won't. This will print a blank. The only time that the seg fault happens is if you try to dereference an address that has, oh well. So there's a difference between, here, yeah, let's kind of, there's a difference between an address that contains a null character, and then there is the null address. And so if I dereference this address here, it'll be like, hey, that's an address. And then it'll go here and it'll say, hey, you've stored null into this address. But this address is null. This is a null address here. So the moment I try to dereference 0, then you get the seg fault. And so the address here afterwards in the 4th position might be 0, and then the seg fault would happen. But you would be, so you will be able to access it, because up here, notice how I'm looking for it. I'm looking for it. I'm just going to the right, to the right, to the right, until I find it. And so what happens here, if we do Bob, it will say size 0, that's good. Size 1, that's good. Size 2, that's good. And then it will say here, and it will say, hey, this is the character. And so it will break out. It won't increment the size, but we do want the size to be 3, right? Right, because this will put us at 2. This while loop will put us at size equals 2. And then we just want the size to be 1 more than the valid index. And so then we'll make it to be size plus plus. And so then what do we say? We're going to say then array is equal to new character of this size. You're welcome. And once the array is now equal to this new character, right? Then we're going to do our deep copy. Let me just come down here and copy this code. Except this is not the right-hand side array. This is, in fact, the... I don't want to call it the array. That's my mistake. Let's just call it A in this case. Let's call it A. And then in this case, it'll be A. Whoops. There we go. So hopefully you guys are okay with this. This is just the parameter constructor, in which it takes in a character array. It goes to the end till it finds a null character. It will set the size properly. It will then allocate an array for its own. And then it will copy in literally every single character except for the null character. Because we're storing the size here. So now that we have all of that stuff, we can finally get back into the operator overloading. And in fact, for your assignment, you'll have to do every single one of these things. You'll have to do a parameter constructor, a destructor, a copy constructor, and an assignment operator overload. So it's a good thing that we did those. So remember what this one does. Loaf times 3 becomes loaf, loaf, loaf. So what we have to do is we have to make the array to be 3 times as large as it was, and then we have to copy over the characters over and over and over and over and again. So let's first increase size by right-hand side. Let's make a new one. Int size new is equal to size times 3. Times not 3, but times the right-hand side. And then we're going to make a new array. Let's do that one. A new character array is now equal to a new character of size new. Hopefully you guys are okay with this so far. And so then now we just have to copy everything over. So I'm going to do it this way. This kind of stuff takes some practice to kind of just think about for loops and stuff in your head. But let's do the right-hand side here. So we're going to have one for loop. Whoops. We're going to have one for loop for the integer that we're multiplying it by, and then we're going to have one integer, one for loop for the original size. Okay. And so what I have to do is I have to fill in first. Let's say we're doing loaf. And so now I have a new array that looks like this. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And so now I have to fill in these things one by one. So the first thing I have to do is the L. And so I'll just show you that this code here will work a little bit. So what I want to say is the array new located at the 0th index, right, is equal to the array, the original array located at the 0th index. And then we'll say 1 and 2. So what we're actually going to say here is probably J and J. And so let's see how that works, right? So then it will go up to 1, and this will give us our O, and then this one will give us our A, and then this one will give us our F. And so then this now, I, will become 1. It will become 1, and then we come back down in here, And then this code will actually go back and rewrite the L. And then we'll go back and rewrite the O, and then rewrite the A, and then rewrite the F. And then it will do that again. So if I can make a change anywhere in these for loops to get it, so then it puts the L here, and then the O, and then the A. Does anyone have any ideas? You could say maybe you can't change the for loops, but you can change this line of code. And I just want you guys to think about it, because this is good to think about. So if you have any ideas, let me know. But eventually here, I'll go ahead and give you the answer after a few moments. We need to see, Red Rose says we need to add it to self under the J loop. Oh, are you saying something like J? Yeah, I like how you guys are thinking. J plus 4 works, right? So I'll give Awful's solution, right? Let's do it this way. What Awful says is something like J plus 4. But what is that actually doing? What it needs to do is it needs to add the size of the string, right? And so the size of this string is actually probably J plus size. And so that kind of works. But here, I'll give you the simplest one. What if I say J times I? And so when I is 0... Oh, hold on. Hold on one moment. I think it's J times I plus J. My mistake. So that should work. So when I is 0, we're going to get 0, 1, 2, 3, and then it should stop. And then I will be 1, so we'll have 0 times 1. My bad. Let's do it this way. I had to work it out myself too. There we go. So we do the size here. We'll do the size here. And so this, when I is 0, will give us 0, 1, 2, and 3. And then when I becomes 1, then we'll do 1 times size, which is 4, plus 0. So we get 4, 5, 6, 7. And then I becomes 2. And so then it will be 4 times 2 equals 8 plus 0 is 8. So 8, 9, 10, 11. You guys happy with that? It's kind of a nice, simple little for loop that goes on there. And so that will actually give us the loaf. So we'll continue on here. We're not going to be able to fit in all of our operators today, but I'll give you enough to get started on the assignment. We did do the assignment overload, and we did do the multiplication one. This will be helpful to you guys. Just take note on this. When you're writing the assignment, I'm about to give you a hint. So notice all this code that we just wrote for this multiplication operator. So now I want to do the other way, right? Let's say I want to do int times string. So obviously I could copy this code up here, but does anyone have a nice idea onto how I can just write one line of code here? Actually, I need to do one. We're not done here yet. I'm getting ahead of myself. If you have the idea, go ahead and type it out, but I'm getting ahead of myself. There's a few things that I forgot. This is not a member function. So I need to do the left-hand side array here, and I need to do the left-hand side dot size. I need to do this left-hand side dot size. I need to do this left-hand side dot size. Yeah, Sibe, you were totally on top of it, and I'm getting way too excited over here. Yeah, remember that this is This has to come by reference too. Please pass it by reference. You are so right. I was getting ahead of myself. All right, and so once we did this, then we just need to change up that that class, right? So now I have to say something like left-hand side array. I don't want the old one anymore, so I got to delete it. And then I also want the left-hand side size to be equal to the size new. And then I want the left-hand side dot array to be equal to the array new. Okay. So we'll just make a new size. We'll make a new array. We'll copy it all over into there by referencing our object. And then we'll delete our old array. We'll assign the size, and then we'll assign the array. Awful says this equals copy. I like that you're thinking about it. But look at this, right? Isn't 3 times, say, I don't know, right-hand side also the same as right-hand side times 3? So what happens? I'm making a small mistake, guys. I'm sorry, I'm a little rusty. Let me show you what I mean. I'm a little rusty today. So if I had this string here, s, and I said s is equal to s1 times 3, I don't want to edit this. I don't want to change this. That's what I'm saying. I don't want to change this parameter. Yeah, so Seabay, even though I'm explaining to you how I got ahead of myself here, Seabay nails it, right? So this one is easy enough. I will actually just say return string CS202. No, not that. We're just going to return the right-hand side times the left-hand side. So notice I just swapped them. And this will call this operator up here. But this is the last edit that I'll make. I actually don't want to edit this one. I just want to make a new one. So I'm going to make a new string. Actually, let's bring it down here. Let's not delete that old one because we want to keep it pristine. And then we'll take the return string and we'll put it here and we'll put it here. And then I'll return the return string. All right. I'm sorry, you can't be here. I'll put it down here though. So everything just stays the same, except we are going to assign it into a new string, and then we're just going to return that one. So that should be good. I want to overload maybe the one other operator real quick. And then we'll just test our code to see if it worked, and then we'll kind of be done. I'll just briefly explain the assignment, because we've only got 15 minutes left. Do you guys have any questions about this? I know that I kind of changed it up on you twice. And so if you are confused, please ask this question so that I can help you understand what I did. But in the meantime, we're going to do one more operator today. And it is going to be the one that we use for cout. Where did I make the return string? I made it right here. And so I called the default constructor here, which sets size equal to 0, and the array will be equal to null. And so all I did was I declared a brand new one right here. And then I just assigned these values in this array that we already calculated. And then I returned it. Does that answer your question? That'll be our new one. But everything else should work just fine. And we'll test it anyway. So the one that we're going to do is the cout, just so we can test our operators. So that's what we call the insertion operator. And what is the insertion operator? It actually takes, this is an I stream. And so this is how these ones work. Okay, so it's going to return an I stream. It's actually going to return it by address, or it's going to return it by reference. Then we're going to do an operator here. And this is the cout operator, right? So we're doing that one. And in this operator, we take an iStream in, and we take in a string CS202 some object. This will be the right-hand side. I guess this will be the left-hand side. The first thing that we should do is we should make this a friend function. So I just come up here and I type in friend. I'll drop it right there. And now all I'm going to do is print out the array. So this should make sense to you guys. And we'll make it kind of a, well, it's a string, so. So for int I is equal to 0, I is less than the right-hand side dot size. Not size, but size, right? Not the method, but the actual integer. I++. We'll go through, and normally we would do something like cout, the right-hand side located at this array. But it's not a cout, in this case it's the stream. So we'll just send that stream, whatever this is. And so this operator will work with files. It will also work with cout. And then at the end, we just have to return the left-hand side. And why do we have to do that? Because have you ever done something like cout, say 3, and then a comma, and then a 4, and then an end line? So in a way, if we put this in a parenthesis, this operator returns cout. And so then we basically just say cout a comma. And so then we put that in a parenthesis. And so this then returns a cout. And so then we say cout 4. Do you see how that works? And so then we put that in a parenthesis. And this operator returns a cout. And so then we say cout end line. I bet you didn't know that's how that worked. Maybe you did. But that is why these operators return themselves. That is why the operators return themselves. So this one's really easy. Do you guys have any questions about what I did here? I'm just sending this. It's not an iStream. I'm sorry. It's an outstream. Told you I'm rusty. But it's an outstream. I can also check my notes just to be sure. I don't see why I wouldn't. Let's see here. Yeah, I got that right. So that's an outstream. So let's test it, okay? Let's test it, and then we'll look at the assignment real quick, and then we'll be pretty much done for the day. And then let's say S is equal to something like S1. This is our assignment. Operator is being called here. This is our copy constructor. This is a default constructor. There's our assignment operator, and then we're just going to kind of cout a bunch of stuff first to start, to make sure that everything is working. So if we cout S1 end line, then we should see loaf. If we see out S2, we should see Patty. If we see out S3, we should see Loaf. If we see out S, we should see Patty. So let's go test that real quick to make sure our code compiles. I'm probably logged out here. No, I'm not. Oh, I'm not connected here. Whoops. Should be there. Except maybe it's not part 1, but it's part I. All right, so we got some errors, but we always do. So it says here, and what is this thing it's talking about? It's talking about this operator here, and I know why. I made a small mistake. Recall that when I changed this, I didn't change my friend, right? So I have to come up here and I have to change my friend. Okay, so that will fix that part. See, it's telling me that right-hand side size is private, which is true, but I know that those functions are friends, so something went wrong there. Next, it's saying right-hand side. It looks like I used the brackets here. And we don't really have too much time to go over that. That is a super easy operator to overload. But we'll just access that array inside there. Okay, so that'll fix that part. And then this is a warning. Perhaps it would prefer us to do a constant array. And let's give that a shot. So that's just a warning, but it will still compile. Hopefully that stuff all works. Nice, that fixed it. That fixed it. So it will be happy with you if you make this constant, meaning that you're not allowed to change whatever is in this array. Were you telling me how I might fix that warning with the single quotes? Well, let's see how we do here. I didn't want to open Spotify. What am I doing? So that compiled. And let's /a.out. I got a Z fault. Woo! All right, folks. Not to worry. Not to worry. I assure you that this is mostly working. I will spend the time to debug this in just a moment, okay? So hang with me if you'd like, and I will debug this entirely on stream. I know some of you guys like to watch that. But first, for those of you who are not interested and rather me tell you how I fixed it next class, because next class we will still be going over operator overloading, and we will be building off of this code still. So we won't be moving on from it. So you can catch up next time if you'd like. But if you would like to see me debug it, hang around at the end of the stream. I'm just going to show you the assignment real quick. And with the knowledge that you learned today, you should be able to get started and maybe even finish, depending on how well you kind of understand how these operators work. So if you go to Files here, not to the test answers, but rather to the assignments, you'll see that assignment 6 is here. And then here's the PDF. This PDF is only 3 pages long. Okay. And so what are we working with? We're working with a, if you can't tell, it doesn't like it like that. Let me pull it up here instead. We're working with a matrix class. It's a 2x2 matrix class. So here it is. We've got a header file for it. It's a 2x2 matrix. And then we've got an input file. I gave you some sample output. And you've got a main file. This is main. And so all you have to do is develop a matrix 2x2 class and overload a bunch of operators and do some of the constructors, right? So there's actually a few things. Parameter constructor, copy constructor, destructor, and 16 total operator overloads. 16 number is pretty daunting. It's pretty big, but really most of these will only take one line of code with some intuition. I would say the assignment operator probably won't take one line of code, but the rest can take one line of code. And maybe also the plus, plus, minus, minus, they'll probably take 2 or 3 lines of code. But the rest can all be done very simply. So you've got to do some addition operators, some subtraction operators, some multiplication operators. You have to do the plus, plus, and the minus, minus. We didn't go over this today. We will go over it next class. But I explained to you how they work, so you should be able to figure it out. And so I'll let you read this part. I tell you that I would recommend completing them in this order, such that you start with the parameter constructor, the destructor, then do the bracket and the assignment overload, and then do the copy constructor, and then all of the remaining operators can follow. And if you use these things like the bracket and the copy constructor and the assignment overload and the parameter constructor, if you use these things in your other operators, your life will be very easy. Kind of like when we use the assignment operator to overload or to make our copy constructor, right? And so I kind of give you all the formulas here. So for some of them, you're going to want to come here to this folder that says formulas. And I just uploaded some PNGs. So I just tell you how I want them. They're very straightforward. But if you're doing the addition of 2 matrices, I just want you to add each element. Same with the subtraction. If you're doing multiplication, this is actual matrix multiplication down here. I know you can't see it behind my face, but I give you the formulas. So just copy this formula here. This one will probably be the hardest, though it's really not too difficult. I also show you how I want the matrices plus an integer to look like. They're very simple. And I also show you how I want the matrices that use an integer first plus the matrix. So you can just look at those formulas for most of them. You can look at them for at least all of these. And then for these ones, I just tell you how they work. Where did I say? So here's the bit about the plus plus and the minus minus. Here's the bit about the insertion, the bit about the extraction, the bracket operator, and the assignment operator. You just compile it and you submit it. So we'll run it. I'll also show you some of the code. This one is mainly, you guys are just going to have to get in there and do your own code. It's kind of by design. So main is given for you, and you can see that in this file, I kind of comment every single thing that I'm doing. And so you can see here, I'm just doing some additions, some subtractions, some multiplications, some plus pluses, some minus minuses. We do an assignment operator. We do a bracket operator. Up here, we do an extraction operator. We're always using the insertion operator. And I also make you test the parameter constructor and the copy constructor. So I'll just run it real quick. And then I'm going to debug this thing. If you guys have any questions before you're going to go today, please go ahead and let me know. But you can see here that this is what the output looks like. It's just the output of what the matrix looks like. I misspelled subtraction. But that's it, all right? So it's pretty straightforward. Go ahead and get started on that. And use Valgrind to make sure that you have no memory leaks. So you're welcome to go now if you'd like, but I am going to just see if I can quickly figure out where I'm getting a seg fault, which means I'm probably dereferencing a null pointer somewhere. And so maybe we'll do some print statements. So whenever I get seg... Well, actually, let's do valgrind. Some of you guys haven't seen me use valgrind before. Valgrind will tell you where the seg fault happens. So let's try that. So I'll say valgrind dash... I think it's dash dash leak check equals full dot slash a dot... Oh, I gotta compile it actually with my dash G first. So let me show you that. I gotta put dash G there on the end because I want to see the line numbers. And then I'll do valgrind dash dash leak check equals full dot slash a dot out. All right, let's see here. It's a little big for me. Whoa. Oh. Oh my gosh, folks. Oh, it's infinitely looping. Ah. Valgrind was saving the program from dying there, which I'm not grateful for. So maybe I'll have to look into this. Let me see if I add these on the end, if it will fix it. Because I would expect that it would do this automatically. I think it should do it automatically. And if it's not, then I'm going to have to revisit some of my stuff here. But I would hope so, because that's kind of... I don't know how they do it for the string then. I know you can't see it right now. I'm just going to see if I get the same seg fault or not. And I do. And so maybe it is in here. So the destructor is totally fine. I'm guessing it's in here. Oh, I know why. Guys, I'm a huge goober. Guys, I'm a huge goober. What did I do here? What did I do here? This is not the size that I want to be assigning. This is not the size at all. This is a different size. So this size is like, well, I don't know. I think that'll fix it. I think this size was some garbage value, and then I was just going off into oblivion. So let's see if that works. I know that wasn't a very awesome debugging process, but hopefully it... Oh my god. Okay. It worked. That was it. That was it, guys. Can you believe it? I'm a huge goober. All right, so I know that we're a little bit over. I just want to test out my multiplications real quick. We'll only do 2 of them, and then we'll be calling it for the day. Times 3, and then let's do maybe a times 1. Thanks, guys. Thanks. And let's try to break it. Let's do a times 0, and let's do maybe a size 10. Hey, look at that. Look at that. This is loaf times 3. That's patty times 1. This is loaf times 0. And this is patty times 10. Cool. We did it, folks. So I hope you enjoyed the stream. Welcome back from spring break. I'm always available for questions. I know you guys know that. Office hours are in 10 minutes. Go ahead and take a look at that assignment, and I'll see you guys on Wednesday. Thanks for hanging in there and with me. I appreciate you guys. Happy Monday. See you later.